Welcome to Healthcare Workflow Process Improvement, Process Redesign, Lecture C. The objectives for this lecture are to propose ways in which the workflow processes in healthcare settings can be redesigned to ensure patient safety and increase efficiency in such settings, and use knowledge of common software functionality and meaningful use objectives to inform a process redesign for a given clinic scenario. We talked about Big D and Little d earlier in Unit 6. For large software systems, such as electronic health records, we distinguish two types of design. Big D, design of the software itself, and Little d, configuration of the system to make it work for a particular clinic. Importantly, to select an electronic health record that matches well with clinic needs and to configure one once it has been purchased, you need to be familiar with the functionality of such systems. The diagram shows that there are a few different systems with which clinics should consider EMR interfaces. These include a practice management system, system at a local or central lab, diagnostic imaging equipment, or image picture archival and communication system, PACS, patient portal, and local health information exchange or connections with other local healthcare facilities with whom the clinic has care or business relationships. Designing clinic processes requires knowledge of these types of systems and of the functionality that they possess. Further, selection and implementation of an EHR is complicated by the fact that vendors sometimes bundle functionality from one or more of these systems into an EHR. For example, some systems available have both Practice Management System, PMS, and EHR functionality. Further, other systems have lab functionality to support tracking and result storage of labs done by the practice. Still, other systems may include optional patient portal functionality. Needless to say, an early step in the analysis is to create a context diagram like that depicted here. Such a diagram quickly orients the analyst to opportunities for interfaces and to existing interfaces that must be taken into consideration. The next slides will cover common functionality of each of these systems. The PMS systems handle administrative clinic office functions, i.e., administrative as opposed to clinical information. It stores patient demographic information, provider information, and patient insurance information. It is used to schedule appointments, store contact information for third-party payers, perform billing tasks electronically, including facilitating medical coding with ICD-9 or ICD-10, track status of claims, and generate reports on stored information. This is common functionality that is available in PMSs. Clinics may use some or none of these. Two meaningful use eligible provider Stage 1 objectives pertain to common PMS functionality. The first is a core objective. Record all of the following demographics: preferred language, gender, race, ethnicity, date of birth. The second is a menu objective. Send patient reminders per patient preference for follow-up care. Meaningful use objectives are covered in Unit 6, Process Redesign, Lectures D and E. There are three main points of interaction between a PMS and an EHR. The patient demographics are captured at registration and pushed to the EHR. The scheduled appointment in the PMS is pushed to the EHR, and the diagnoses and services are captured in the EHR and pushed to the PMS for billing. Clinics may not want to create all of these. Furthermore, some EHR software may also perform some of these same functions. For example, the EHR may handle appointment scheduling. In cases like this, decisions must be made about which system will handle the task. In other cases, when EHR software is bundled with a PMS, the clinic may wish to migrate from its PMS to the new PMS-EHR combo. Thus, implementation would also include a migration of the PMS. Clinics without a PMS may benefit greatly from an EHR that is bundled with a PMS. LIMS is a general term for software that handles and automates the functions of a clinical or research laboratory. A clinic may have or need an LIMS to manage lab tests performed in the clinic. For example, if the clinic has analyzers for blood chemistry or blood counts. Clinics may send samples out to local or central labs. In this case, the clinic may want an interface with the lab's LIMS. Either or both of these situations may apply. Analysis and redesign means figuring out which of these situations exist, finding appropriate software, and designing processes to fully leverage the software. Importantly, incorporate clinical lab test results into EHR as structured data is a Stage 1 meaningful use menu objective, i.e., practices can use incorporation of lab test results into their EHR as structured data as part of their claim for meaningful use incentives. The general functions of a LIMS system include printing sample labels, sample tracking, lab instrumentation interface, EMR/EHR interface, which includes ordering lab results and reporting results, as well as lab quality control support and billing support. LIMS EHR workflow differs based on whether the lab is in the clinic or external. Some example workflows are: lab tests are ordered in the EHR and then pushed to the LIMS where label printing is enabled at the clinic. Lab tests ordered in EHR and codes for labs are pushed to the PMS for billing. LIMS lab test results are pushed to the EHR. Whether or not there is an electronic interface in a clinic, LIMS with lab analyzers make a difference. Where there is no interface, the lab results will need to be entered into the EHR by hand. Whether or not a clinic EHR can interface with an external lab also makes a difference. Where there is no interface, lab results will need to be entered by hand, as will the process of figuring out which results are clinically significant, which patients need to be contacted, and who is following up on those calls. When a clinic provides image-based diagnostic testing services, the imaging device will produce images that are static, like X-rays, moving pictures, for example, endoscopy films, or both. These images require storing and organizing, usually done by a picture archiving and communications system, PACS. Clinics may have just an imager, for example, an X-ray, or may also have a PACS. Images may be viewed in the imager software, or if integrated with an EHR, through the EHR. Imager PACS EHR workflow works in 3 ways. The image is ordered in the EHR, and the order is pushed to the imager. The imager creates the images and pushes them to the PACS, and the images from the imager, or PACS, are viewable through the EHR. Patient portals are used by healthcare facilities to interact with patients. Most offer self-service features, such as appointment scheduling, advanced registration or payment, viewing health data, and communicating with providers. Portals can come with the clinic EHR or be independent systems. Independent systems require integrating or interfacing with the EHR. Also, since patient portals are for patients, they are provided over the web. Many clinics do not have the capability to host web software, and thus use vendor-hosted portal products. The DukeHealth.org site provides an example of a patient portal. One of the meaningful use Stage 1 eligible provider core objectives is the ability to exchange health information. An HIE, or Health Information Exchange, is an infrastructure, usually regional, that facilitates the exchange of health information between facilities. Note, it is the exchange of information rather than point-to-point transfers of information. The United States is also working on a National Health Information Exchange to which the state or regional HIEs will connect. There are many workflows associated with HIE. Details of the workflows depend on whether point-to-point interfaces are built or there is a regional or national infrastructure. Some examples of HIE workflow include: the patient is seen in the local emergency department and a summary of care is pushed to the primary care provider. The primary care provider refers a patient to a specialist and pushes relevant information to the specialist. After seeing the patient, the specialist pushes back a summary if care or clinical interpretation is derived from the specialist visit, and an immunization or a reportable disease is documented in the EHR, and the EHR pushes this information or notification to the local health department. Meaningful use requires exchange of such information about a healthcare visit or episode of care. Now we will do a process redesign example. After these instructions, pause the slides. A fairly new 5-provider clinic has been in business for 7 years. They have a practice management system in place, and they are fairly happy with it, but are not determined to stay with that product. The diagnostic services that the clinic provides are blood counts from an in-house analyzer and urine dipstick, glucose, ketones, urine blood, protein, nitrate, pH, urobilinogen, bilirubin, leukocytes, and specific gravity, and pregnancy. Other blood-based samples and urine are sent to the local office of a national laboratory testing chain for processing. Today, results are returned to the lab on paper sheets. The practice currently does not do e-prescribing but would like to. Answer the following. 1. Draw a context diagram for this practice. 2. Discuss 2 things you need more information about to be able to make redesign recommendations. What do you need to know to make a recommendation? 3. Discuss 2 redesign recommendations that you can make based on the scenario. What EHR functions are needed? 4. Discuss the system interfaces that you think are needed. Work these questions by yourself first. The following slides will review the answers. Pause the slides now. Question 1. Your context diagram for item 1 should have similar components in it. Let's walk through this diagram. At the top left, the scenario mentions that the practice had a practice management system. It is a given that the EMR should interface with that system. In the scenario, there was no mention of whether or not claims were sent electronically to a clearinghouse or to third-party payers directly. So the diagram shows a dotted line and question mark to denote uncertainty. Aside, I denote all areas of uncertainty on the diagram to keep them from being forgotten. Moving clockwise, the scenario mentioned using a central lab, local office of a national lab testing chain. Moving clockwise again, the scenario mentioned that the practice did blood counts in the office using an analyzer. This represents an interface. Moving clockwise again, there was no mention of interfaces with a local HIE or local healthcare facilities, or of the need for a patient portal or of appointment scheduling, so I noted as an area of uncertainty. Lastly, the practice does not currently have, but did mention as a future need, e-prescribing. This diagram uses different color lines to represent the as is from the to be, and the uncertain and need to check items. Importantly, your diagram may have had a completely different shape, and that's fine. The shape or layout of the diagram is not important. What is important is that you had the right entities and relationships. Question 2. 3 things about which you need more information to make redesign recommendations. What do you need to know to make a recommendation? Are there local HIEs or health facilities with which you need an interface? Patient Portal is a key opportunity to gain efficiency by relocating control over scheduling, etc., to the patient. There was no mention of this in the scenario. Likewise, there was no mention of electronic claims. To make a recommendation, you need to know what the current capability is, as well as the desire to perform or automate these functions, and in the case of interfaces, if the other party is capable of an electronic interface. 4 possible redesign recommendations are e-prescribing, which requires EHR with this functionality. Integration with an existing PMS or EHR that has PMS functionality. Migrating data from a current PMS will be a harder implementation, but workflow and ongoing maintenance may be easier in the long run. The patient portal can be used to increase self-service opportunities and automated appointment reminders. System interfaces include a PMS, internal lab analyzer, central lab, e-prescribing, and patient portal. You may need to gather more information about HIE and interfaces with local healthcare facilities, i.e., are there any with which the practice has contractual relationships? This concludes Lecture C of Process Redesign. In this unit so far, we have addressed how to identify the factors that optimize workflow processes in healthcare settings, describe how information technology can be used to increase the efficiency of workflow in healthcare settings, identify aspects of clinical workflow that are improved by EHR, propose ways in which the workflow processes in healthcare settings can be redesigned to ensure patient safety and increase efficiency in such settings, and use knowledge of common software functionality to inform a process redesign for a given clinic scenario.